All right, folks, it's Bass Action, back in action here. In this video, we are going to cover our last two topics related to vectors. We're going to look at the dot product and the angle between vectors. Now, the angle between vectors is different than the direction of angle of a vector. The angle between vectors is actually going to be between two separate vectors. So before we can get to the angle between vectors, we need to understand the dot product, because the dot product is part of that formula. So looking at the dot product here, we're given two component forms of our vectors, and the dot product is actually much simpler than it might seem. What we're going to do is we're going to take each of the A components and we're going to multiply them, hence the name product. Okay, so A sub 1 times A sub 2, and then we are going to add that to the product of the coefficients on the J's, on the J component. So B1 times B2. So you'll have a single number as your final answer. So I've got some vectors here. Remember, these are position vectors, so they assume they have a terminal or an initial point of 0, 0. And we are going to find these various dot products. So the dot product of V dot W, so I've got V and W, means that I'm going to take my 4 times my negative 3, and I'm going to add that to my 2 times my 5. So that means I'm going to have a negative 12 plus a 10. So my dot product is a negative 2. So these are going to be pretty quick. Our dot product of W dot V means we're going to take our negative 3 times our 4, and we're going to add that to our 5 times our 2. So not surprisingly, we get the same answer no matter which way we do our dot product. So that is our commutativity of the dot product. So it doesn't matter if you do U dot V or V dot U, you're going to get the same answer either way. Just realized I didn't write that answer there. So we're going to look up there to understand that one. Now we want to take a look at these dot products. So we're going to do U dot V. Okay, so we're going to jump over here. Now we're going to do U dot V. So we've got some different vectors, this one and this one. And I'm going to find that product, sorry, 4 and a negative 7. And I'm going to add that to my 2 and my 6. And then I'm going to add that to the dot product of U dot W. So now I'm going to do my U dot W, and here's another way that we can write this. You can write out all your steps, or you can say U dot W is going to be negative 7 times negative 3, and that's going to give you a 21, and 6 times 5 is going to give you 30, so we're going to add that to 30, and of course then if we add all these up, we're going to have a negative 21, we're going to have a 12, plus a 21, plus a 30, and when we add all those up, we're going to get 35. Now, we're going to take a look at what happens when we do U times V plus W. So let's find V plus W. So V plus W says we're going to do a 4 plus a negative 3 is going to give me a 1, and a 2 plus a 5 is going to give me a 7. So that gives me that new vector, and of course my U vector is negative 7, 6. Now, if I find that, that's going to give me negative 7 times 1 is going to give me a negative 7. 6 times 7 is going to give me 42. And sure enough, that gives me 35. So what these two examples want to show us is that this distributive property applies. If I distribute this U vector, so U times this product is the same as this, that the vectors can be distributed. The next thing that we want to look at is what is W dot W. So that's going to give us a negative 3 times negative 3 is going to give us a 9. So negative 3 times negative 3 is a 9. And 5 times 5 is going to give us 25. So W dot W is going to be 34. Then what we want to look at is our magnitude of W, and our magnitude of W is going to be course, the square root of 9 plus 25, and that's going to give us the square root of 34. So you'll notice that these are very, very similar. This is our last property, and what it wants to tell us is that if we take a vector and we find the dot product of a vector with itself, that is going to be the same as the magnitude squared. That's all that property is telling us. Okay, now down here to the law of cosines, we're going to use our law of cosines to prove this formula to find the angle between the vectors. Now, I'm not going to go through this whole proof right now, but I would like you to spend some time and taking a look at that. I'll have a few questions later about this, so spend some time trying to follow these steps. In this video, I really just want to focus on working with our examples here and finding the angle between our vectors, okay? So all we're going to do is we're going to use this formula. You do need to know this formula. We will not provide this one to you. So let's just first quick graph our two angles, our two vectors right here. So I'm going to graph this vector negative 2, 6, and that one's going to go negative 2 up 6. 1, 2, 3, 4, 5, 6. Hopefully I counted that right. And then I'm going to graph my vector v, which is going to go over 5 down 2. 1, 2, 3, 4, 5. There we go. And there is going to be my vector v. And the question that we want to ultimately find is, what is that angle? What is the angle between those two vectors? Now, to find the angle between those two vectors, what we want to do is we're going to use our dot product. So we're going to find the dot product of these two vectors, and that's going to give us, and I like to kind of write it out here. So we're going to say u dot v is going to be a negative 10 plus a negative 12. That's going to be a negative 22. Then what we're going to do is we're going to find the magnitudes of each. So the magnitude of u is going to be the square root of 4 plus 36, or the square root of 40. Don't bother simplifying that. The magnitude of v is going to be the square root of 25 plus 4 is going to be the square root of 29. Now, to do our formula, what we're going to do is we're going to say cosine theta is going to equal this dot product divided by the product of these two magnitudes, square root of 45 times the square root of 29. Now, if you type this in your calculator, remember you will need to use your inverse cosine to actually get your angle for theta. Your theta that it's going to give you is going to be 130.2 degrees. And if you look at this picture, that feels like a very reasonable angle for the theta that we can see in our picture. Now, let's come over here. We're going to repeat the process. We're going to find our dot product. So we're going to go ahead and find u dot v. So u dot v is going to be a negative 27 plus a negative 12 is going to be a negative 39. We're going to find the magnitude of u. That's going to be 9 plus 4, or the square root of 13. We're going to find the magnitude of v, and that's going to give us a square root of, I'm going to scooch this up more for us now. Our magnitude of v is going to give us an 81 plus 36. That's going to give us the square root of 117. Now, to find our angle, we're going to do cosine of theta, negative 39 over our square root of 13 and our square root of 117. Now, when we type this into our calculator, it's going to give us an answer of 180 degrees. So let's go ahead and graph these two vectors, okay, because that feels like an odd answer to us. So if I graph my u vector, I'm going to go negative 3, 1, 2, 3, up 2. So here's my u vector. And then if I graph the v vector, I'm going to go over 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, down 6. 1, 2, 3, 4, 5, 6. And what it looks like is that these two vectors are going in exactly opposite directions. When that happens, if your theta equals 180 degrees, then you will say that the vectors are parallel. Okay, so that's an important answer here. So when you get a 180, you will say that the vectors are parallel. So we're going to do one more example here. Again, we're going to quick find u dot v. Oops. We're going to find u dot v, and that's going to give us a negative 24 plus 24. I'm skipping over the arithmetic now. That's going to give us a 0. Our magnitude of u is going to be 5. Again, I'm skipping the arithmetic because we've done this a lot now. Our magnitude of v is going to be 10. Now, if we do our inverse cosine here, so we're going to say cosine theta is going to be our dot product divided by those product of those magnitudes. Of course, cosine is 0. We know that cosine is 0 when theta is 90 degrees. We don't even need our calculator for that. So again, let's graph these. So if I graph my first vector, negative 4 up 3, 1, 2, 3, 4 up 3. And then I'm going to graph my second vector. I'm going to go over 6 up 8. Have a hard time seeing these. 1, 2, 3, 4, 5, 6. And then I'm going to go up 8. 1, 2, 3. I might be off just slightly. I feel like I'm off on one of these. Okay. We're trying to find this angle. Well, if you've graphed these properly, your two vectors should look like they're perpendicular. And sure enough, if you get an answer of 90 degrees, that also will tell you that your vectors are perpendicular. Now, in the world of vectors, this is called orthogonal. So make sure that you know that word.